Hi, welcome to your lesson on forms of linear equations. In this video, we'll look at refreshing your understanding of different forms of linear equations, and then applying linear functions and modeling using lines. This is clearly a big idea. Linear functions are a huge component of mathematics and other fields. Recently, we learned that for a straight line graph that shows the relationship between two variables, x and y, we have an equation of this form, y equals mx plus c, where m and c are constants. In this equation, the m and c values were called parameters, and the parameters represented something. We have here a linear equation, 2x minus 4, and we can see this m parameter represents the gradient or slope, because we have a rise of 2 and a run of 1, and the c parameter, the negative 4, represents the y-intercept. Okay, let's take some notes. We're going to look at different forms of linear equations because y equals mx plus c is not the only form we know. So the equation of a straight line written in the form y equals mx plus c is said to be written in gradient intercept form. Why is this called gradient intercept? Because m is the gradient and c is the y-intercept. So we call this gradient intercept form. Now let's say we take our gradient formula. We know gradient can be found by doing y2 minus y1 over x2 minus x1. Let's take that, let's rearrange it by bringing this up like this and multiplying by m here, so that part has gone here. Now we have another form. If x2 and y2 is considered to be any point on the line, well, we write any point by using just general yx, so that represents now any point. So now we have a different form. From this, we've created this different form of linear equation. This form is known as point gradient form because we have the gradient here and we have one point here. x1, y1 is 1 point. So that's called point gradient form. It looks like this, just like what we have here. In this equation, the parameters tell you a gradient and a point that lies on the line. And again, yx represents any point, and just like when you write here, we just keep the y and x as it is. It represents any point on the line. Okay, so just to recap, that's gradient intercept form, and this is point gradient form. Let's try a problem. It says find the equation in point gradient form of the following lines. A line that passes through negative 4, 5, and is parallel to the line with this equation. So let's see if you can use point gradient form. And then for the second problem, a line that passes through these 2 points. If you're going to write that in point gradient form, you should find the gradient first and then use either of these 2 points to write it into point gradient form. So let's see how you did. Let's check our work. So in the first one, if the slope of a parallel line is this, then the slope of the line we're looking for has the same slope. And then using point gradient form, so here's point gradient form, we just substitute in the slope or the gradient, and we substitute the 1 point we know, which in this case is negative 4, 5. So that goes in negative 4 for x, which becomes positive because we have negative, negative, and then negative 5 goes in here. So that's point gradient form. In the second one, we take the 2 points, we use our gradient formula to find the slope first, and then we proceed with the same steps. We use point gradient, so we put the slope here, and we put one of the 2 points in these 2 values. So again, x1 and y1 are replaced by one of the points we know. So it looks like they used the point negative 1, 2 right here. You could have used 3, negative 4 as well. And that's why it says or this one. These represent the same line. Okay, so now using these different forms of lines, we can graph them as well. So here's gradient intercept form, and here's point gradient form. But no matter what form you're given here, you should be able to graph it. So what does the first one look like? There's the first line. We can see an intercept, y-intercept of negative 3, and a gradient of 4. It goes up 4 over 1, up 4 over 1. Okay, next one. That one looks like this. It has a negative slope, down 2 over 3, down 2 over 3. We see that slope. And it has no value here, means there's a y-intercept of 0, and that's why it crosses right here. Next one. In this case, you can multiply this through and move the 4 over to get a gradient intercept form. So if you multiply that, you'll notice the slope is -2. So down 2 over 1, down 2 over 1, and so on. And then if you multiply this through, you get 6, and then you subtract 4 from it, so it becomes 2. That shows us a y-intercept of 2 right here. Okay, next one. Well, we've learned that any lines of this form are horizontal lines, so this is y equals 3. All right, a third form, so another form of equations of a line is general form. So we've looked at gradient intercept form, point gradient, and now general form. General form looks like this. Okay, ax plus by plus d equals 0. So basically everything's moved to one side of the equation, and we write it in this order. In this form, you may be told to use integers for a, b, and d. Okay, let's try. Find an equation for each of the following lines. Give your answers in this standard form, or general form, where a, b, and d are integers. So the line with gradient -3 over 4 and y-intercept of 0, 2. So notice you're given gradient and y-intercept. So you should begin with the gradient intercept form and then rearrange to look like this. All right, in B, you're given a gradient and you're told it passes through this point. So this time you're going to use point gradient form. So plug that into point gradient form and then rearrange so it looks like this. All right, let's check our work on those two. Here's the first one. There's our slope, there's our y-intercept. Now this can be rearranged like this. So everything moves to one side. We keep 0 here. And then in general form, we typically don't have fractions. So notice we're multiplying by 4 here to clear away this fraction. And that becomes 3x plus 4y minus 8 equals 0. In the second one, we have a line with this gradient passing through this point. So we begin with point gradient form here. See, we have the gradient here, and there's the point substituted there. Now this we can simplify. Again, there's a fraction here, 2, so we're going to multiply both sides by 2. You're left with this, and now you move everything to one side and get 0 here. So it's written in this general form. Okay, so we're going to try graphing these as well. Draw a graph of this line given to you in general form. And another one, this line, also given in general form. One thing you can do is rewrite it in gradient intercept form. So that means keep y on one side, move everything else to the other side, and end up with y equals something, something, something. That will help you graph it. Let's try. So that first one, as you can see, the 3x was moved over, and then we divided by 4 to get this. Now that is graphable, easily graphable. We have a y-intercept of 2 and a slope of -3 over 4. So down 3 over 4. Down 3 over 4. Okay, try the same approach with the second one. Check that one here. We have, you could have done the same approach, but here's showing a different way. So pause and take a look at this approach here. It's a good way to do it also. When you have general form, it's easier sometimes to approach it this way, where you look for the two intercepts, the x-intercept and the y-intercept. And those are found just by setting either x or y equal to 0. So take a look at the work there. All right, now you need your calculator. We'll be graphing some. So here, using your calculator, your GDC, find the point of intersection for each pair of lines. So here's one line and the second one. Graph both of those and find the intersection point. Now try these two, this one and this one. Well, you cannot enter an equation like that in your calculator, so this one you will have to rearrange to look like this. So from general form to gradient intercept form. And then you can plot them both and find the intersection point. So let's check. For the first one, the intersection point was 1, -2, and for the second one it was 0.286 and 5.571. Okay, here's another one. Solve this equation by using your GDC. So here's an equation. We have this equals this. Well, this is exactly like the last two problems. We have a linear equation here. This is a linear equation, and we're setting it equal to another linear equation. So we're basically saying, when is this line equal to this line? So you can enter this as one linear equation in your calculator, and this as another linear equation on your calculator, and then solve to find the intersection. So there's the two lines graphed. Here's one in equation. Here, I don't think it shows the other one. But anyway, we can find the intersection to be this point here. Okay, now linear functions is the next step we're going to take here. So a function whose graph is a line is called a linear function. That makes sense? You can write a linear function as an equation, such as this, or using function notation like this. So we know already we have equations and we have function notation. You can think of f of x as another representation for y. All right, a little piece of history for you. The term function was introduced by German mathematician Gottfried Wilhelm Leibniz in the 17th century, and the notation was coined by Swiss Leonhard Euler in the 18th century. So linear models. A linear function, which describes the relationship between two variables which are connected in real life, is called a linear model. So now we're talking about using functions to model real phenomena in the real world. A linear model is used to analyze and predict how the dependent variable will change in response to the independent variable. So in other words, how does y change in response to x? But we don't usually use y and x in function notation. We have variables that really connect to the real problem. So let's look at this problem. We have a video streaming service charging a monthly service fee of £6.99 and an additional 99 pence for each 24-hour download rental of a premium movie. The total monthly cost of this service in British pounds is given by this function here, where x is the number of premium movie rentals that month. So find the total monthly cost for a month in which there are 5 premium movie rentals. And B, try B as well. Find the inverse function and explain what it represents for this function. Finally, find the number of premium movie rentals downloaded in a month where the total monthly cost was this. So this is going back to our use of functions. In the first problem, all we need to put in is an input of 5 into the function. So 5 goes in here, and we can figure out the cost when 5 movies are rented. In the second one, to find an inverse, remember we changed the x, or we swapped the x and y values, and we solve again for y. So our inverse function becomes this. And this represents the number of premium movie rentals downloaded during the month. Finally, we can put into the inverse function, we can put in this cost now. So this function, if the original function found us the cost based on movies as the input, the inverse tells us the number of movies rented based on the cost. So the cost goes into the inverse function, and it gives us the number of movie rentals. It's doing the opposite. It's doing the opposite function that the original one did. That's what an inverse does for us. All right, here's another problem. Try this one. Read this and try these problems. Okay, so here is first you can use any 2 points on here to find the slope. The slope can then be used to create the function using point gradient form. So now we have a function. That function can then be applied in C to answer that question there. So the steps again were find the slope, use the slope and a point to find the point gradient form of the linear equation, and then put in the values once you have the equations to solve what you need. Last one for you here. We have a Celsius to Fahrenheit conversion, which we've talked about already. Let's find a linear model that represents that. So again, you can find the slope, and then you can use any of these points and use the point gradient form to create an equation. Once you have that model, you can apply it to these problems. So here are the answers here. Here's our slope. Here's the model we can create as a result, and then using the model to find values here. And check your answers for C and D as well. Okay, you can do it. This is a great topic. Kind of review. I'm sure you've been dealing with linear functions for a long time, but it's important to build up these skills. You'll see how this brings us just another step closer to calculus, which is coming soon. All these linear concepts are important. You can do it.